Yes, hello. So in the previous video we looked at how to create some basic circuits, some basic resistance circuits using a DC battery and some resistors. Then we added voltmeters and ammeters. So in the next video we are going to look at doing the same thing with an AC circuit, and then also look at how to use an oscilloscope, okay, and the instrument category. Okay, so yeah, let's get right into it. I'm going to just add it in the same template. I'll just add an AC circuit here. I'm going to just put it somewhere down here. So go back to component mode, put a V sign, and we're still using resistors. So we just put, let's just use two this time. Put one here and one here. Then rotate them. Then let's add the measurement instruments. So AC ammeter, I'll put it here. Okay, since those are in series. Then an AC voltmeter, I'll put one here and one here. So we make a connection through the ammeter, through the resistor. Oh, it did not make the connection. There, then there, and then there. So we make the connection to that point, and that point, this point, and that point. Okay, somewhere there. I think that does it. So we need to set some values here. Okay. So yeah, we just leave this as default, the DC offset. We only need to change the amplitude and frequency. We forget everything else. Okay, so in order to get a maybe 230 volt 230 volt AC, now that is usually root mean square value, so the amplitude needs to be higher than that. So that's basically 230 times root 2, which should give us around 325. So that's our amplitude. Now for the frequency, we just put, let's put, for the frequency, we are going to put, it's 50. We are using 50 globally, except US that uses 60, US and Canada, and maybe some other part. So that is it. So let's run the simulation and see what we have. So we have 0.01 amps. This is SC, and it's also root mean square value. And whatever we are having here is root mean square value. So that is a plus 115 and plus 115. So if I add this with this, I should get the root mean square value of the voltage of the source. So this is 115 and 115. It should give us about 230. It's exactly 230 volts. Okay, which is what we require. So now what we are going to do is to we can just vary the resistance a bit to increase the current. So let's set this to maybe not too low, maybe 500 ohms, and we can set this to 300 ohms. we run the simulation again, okay, we run the simulation again, this is what we have. The current increases obviously because of low resistance, and then most importantly, if we add this figure to this figure, we should get around 230 volts root mean square value. So let's go ahead and add an oscilloscope and visualize these signals, okay, and also learn how to use an oscilloscope. So yeah, I'll just stop the simulation, and then I'm going to add an oscilloscope, but I'll be using okay, let me just add that oscilloscope. Let me make the connection with yeah, this is the one, so I'll place it somewhere here. That is okay. So we are going to get a signal coming from the source, from that point, then a signal of the voltage somewhere here, okay, that voltage in between. Okay, so that is all we need, because voltage here, and we can't get a voltage here because it will be a zero, because this part is usually earthed, okay, it's usually earthed, so we don't need to make a connection here. It will be the same thing as making a connection at this point, which is our neutral point. So we can only get a voltage from this point and this point, okay. Yeah, so we're going to run the simulation and see what the oscilloscope gives us. So if I click run, this is what the oscilloscope gives. Now I can alter the values of these so that I can visualize the signal inside that window. The window is usually very small, the visualization window, so you can always lower this value so that so what we are actually doing is setting how much each box is worth, okay. Each box in the grid, we're basically setting what it should be worth, and in so doing we are altering the shape of the signal. So if we want each box to represent a very small value, then obviously the value the signal is going to expand and go out of the window that we are using for visualization. So in order to but of course it will be more detailed if it's larger, it will be more detailed, okay. So the larger you make it, the more detailed you get. We can leave it there and then change the position. You can try to center it. So at the center it should be at 0, 0 there. It is still going out, so you can try to increase this. So make maybe a fine tune and make sure it's at the edge of the grid line. So same thing here. So it's exactly in the middle. Now these other channels are for the, I think the pink channel and the green channel. We don't have any signal there. We can go ahead and turn these off, okay. And then yeah, we can do the same thing for the blue channel. We set it at this is 12.42, okay. Yeah, maybe that 12.42. So that is the blue channel. So 12.42. and then 12.42. Okay, that is hard to achieve. I have about 12.5, but that doesn't matter. What matters is making sure it's visible. So I think 2, that is at 2, and then this small part is pointing here. So this is actually giving us 5 millivolts. Yeah, it should be, no, it's 5 volts, and here we are having 12.42 volts. Otherwise millivolts will be pointing here, and these are just decimal for the decimal part. Okay, this will be the decimal part. So if they are both pointing here, then we have exactly 2 millivolts, and 2 point something, then we increase, we go over to 3, and so on and so forth. But that doesn't matter. Let's set it back to where it was, 5 millivolts. So 5 was somewhere there. Okay, now we can try to reduce the time by actually changing this. We are changing it to 2 milliseconds. Okay, without altering the peak to peak. Peak to peak is the same, but we're only altering the time on the horizontal. Okay, so we are now each box horizontally represents 2 milliseconds. Okay, so you can use this if you want to compute the frequency. Okay, because you can get the wavelength peak to peak by counting the boxes from this peak or maybe from the middle part to actually from this peak. It's easier to count from this peak to that point. From that point to that point, that will be one wavelength. So the number of boxes in between should represent the wavelength, so you can convert that, actually the period. Okay, they represent the period, so you can get the frequency from period is equal to 1 over f. So by that we be able to get the frequency. Okay, so same thing with this. You can compute from this peak to this peak, then make 1 over f. Yeah, so since this is the same signal, the same AC signal, it should have the same frequency, which is the one we set, 50. Okay, yeah, so we can try to count and see if we get 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So those are 10, and each of them is 2 milliseconds. So times 10, that will be 20 milliseconds. But you have to convert to seconds, and by that we are dividing by 1,000. So 20 over 1,000 is the same as 2 over 100, which is the same as so 2 over 100 is the same as 1 over 50, and that is t. So your t is 1 over 50, and so the inverse should give you 50 Hz. So same thing, we can try to count these from here to around there. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 2 milli, we should get 20 milli over 1,000. That is 2 over 100, and 1 over 50, and your frequency is the inverse, which is 50. Okay, so that is that. We can try to see the peak to peak value. We want to be sure this is about 325, the one we set. This is 1, so just count from here to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that is 18. Now 18 multiplied by the yellow we have, so that is 18 times 12.42. And I need a calculator for that. I don't know if I have one. Let me see if I have one calculator here. So 18 times 12.42, right? That is 18 times 12.42. So we get something like 223.56. Okay. This is the yellow signal. This isn't right, I think. It isn't right. Yes, alright. So I figured out what the problem is, and is because I forgot to ground. I forgot to add a ground here. So yeah, that is required if we are to get a proper AC signal. So I'll go here, terminal, click the terminal button, terminal mode or whatever, then we're going to select ground with that label. So we come and draw it here. So add ground to that point. Then if I reconnect this to that point and I reconnect this to that middle, that should do it. So if I run, we should get something like that. And if I try to move, let me just center everything 0, and also center the blue there. And so I'll just set both of them at 50, so that maybe I can try to fine tune this signal. Let me move a little bit to make sure it touches the grid line so that we can easily count the boxes. I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14, and I'm going to multiply 14 by this figure, 463.83. So going back to my calculator, we have 14 times it's 46.83, and this gives me 655.62. Now this is the peak to peak voltage. So the peak voltage should be, just divide this by 2, and it's around 327.81, which is about what we need, right? So Now if we need to get like the root mean square voltage, we divide this again by root 2. So divide by okay, now I actually need a value for I don't think I know how to use this calculator. Let me see if we have scientific. So I'll start again. This was 14 times 46.83. Okay, this is 46.83 gives us that. Divide by 2, we get that, and then times the root. We should have a root here. Okay, I don't see the root, but if we divide by root 2, we should be able to get that much. Let me see if we have a function we can use here. There's nothing. Okay, we should be able to get the square root. Okay, should be divide by 2, and then we add the root 2. Well, it still doesn't make sense. This division is crazy. Okay, yeah, division is crazy, but on a normal calculator it should give you about 230. Okay, that should be the right value. So I don't know what this is. Okay, yeah, but you can do the same thing for this. Count. This is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 multiplied by 50. That should be 400. So 400 divided by 2 should give you 200. And now that is peak voltage for the blue. You can get the root mean value. Okay, but now that is only voltage at this point. Okay, so voltage between this point and earth. Okay, so voltage between this point and earth. It's not we can't, if we want to get the voltage between this point and this point, then we just subtract the voltage we got between, because this is between this point and earth. So the one we got earlier, we just subtract the one we got for this part in order to get the voltage that this voltmeter would indicate. Okay, I think that pretty much makes sense, right? Because for the blue channel we are getting the voltage from here and earth, and the yellow channel gives us the voltage from here and the earth. Okay, right, so that's it for this tutorial. Yeah, maybe we can just make a printout of this, so, and we keep it as a PDF, maybe for submissions or whatever. You can just go to file, yeah, it's actually a file, then print design, or whatever this is. You can just do not display the message again, so then click OK. Now we can center the plot, and also our page is in portrait and yet the template is landscape, so you can switch this first to landscape, and then see with normal fit, because we are printing on an A4 paper, and yeah, so we are printing on an A4 paper, and the problem is our template is A3, so we either shrink that, or there's actually no option for the A4 printer here or whatever. Under advanced options there's nothing like that, but we can choose to print in color. As you can see, they are now colored for black and white. So color, or monochrome, but I will just choose color. So I'll just make fit to page so that it fits to page, or you can get even a smaller size if you want. Okay, but yeah, that is okay. So the file name is we are printing Microsoft PDF, so okay, let's click OK, and we're calling it basic something basic. Okay, so this one basic, and yeah, just the name basic is enough. We'll get, yeah, so whatever has been generated, we can always find it in this folder, the folder where you save your work. So yeah, that is what I get. If I try to zoom in, okay, I'm actually having a very fine print here. Yeah, so you see, this is a very fine print. If I zoom out and try to see these details, okay, yeah, even the timestamp is there. Okay, so this is a very fine print. Yeah, you can keep it and or do whatever you want with it. Okay, so that's it for this tutorial.